Good morning, all of you. I am Dr. MP Singh, Department of Mechanical Engineering, JECRC, Jaipur. Today, I will discuss about the psychrometry. Psychrometry is a part of refrigeration and air conditioning. Now, what is refrigeration? Refrigeration is the process of removing heat from a substance under controlled condition. Or we can say, it also includes the process of reducing and maintaining the temperature of a body below the general temperature of its surroundings. In other words, continued heat extraction of heat from a body whose temperature is already below its surrounding. Or we can say, it means continued heat is extracted from a body whose temperature is below surrounding. Air conditioning. It is the study of condition of air, that is simplifying and maintaining desirable internal atmospheric conditions for human comfort, irrespective of external condition. Or when we talk about in as term of air conditioning, then we can say it is the maintain the temperature, purity of air, circulation of air, and maintain the humidity. Now, psychrometry. What is psychrometry? It is the science dealing with the physical law of air, water, vapor mixtures. When designing an air conditioning system, the temperature and moisture content of the air to be conditions and the same property of the air needed to produce the desired air conditioning effect. In other words, we can say that psychrometry is the study of moist air or mixture of dry air and water vapor. Now, what is dry air? The purpose of the pure dry air is a mixture of number of gases such as nitrogen, oxygen, carbon dioxide, hydrogen, argon, neon, helium, etc. Now, the molecule mass of dry air is taken as 28.966 and the gas constant of air is equal to 0.287 kilojoule per kg Kelvin, or you can say 287 joule per kg Kelvin. The molecular mass of water vapor is taken as 18.016 and the gas constant for water vapor is equal to 0.461 kilojoule per kg Kelvin, or we can say 461 joule per kg Kelvin. Moist air. It is a mixture of dry air and water vapor. The amount of water vapor present in the air depend upon absolute pressure and temperature of the mixture. Saturated air. It is a mixture of dry air and water vapor. When the air has diffused the maximum amount of water vapor into it. Now, humidity. Moist air and humidity both are different. When we talk about in terms of the humidity, then it is the mass of water vapor present in 1 kg of dry air and is generally expressed in terms of gram per kg of dry air or gram per kg of dry air. It is also called specific humidity or humidity ratio. Absolute humidity. It is the mass of water vapor present in 1 meter cube dry air and is generally expressed in terms of gram per cubic meter of dry air, or we can say gram per meter cube of dry air. Relative humidity. It is the ratio of actual mass of water vapor in a given volume of moist air to the mass of water vapor in the same volume of saturated air at the same temperature and pressure. It is the important condition or essential condition that pressure and temperature should be same. Now, dry bulb temperature. It is the temperature of air recorded by a thermometer when it is not affected by the moisture present in the air, and it is denoted by dBT. Wet bulb temperature. It is the temperature of air recorded by a thermometer when its bulb is surrounded by a wet cloth exposed to the air. Such a thermometer is called wet bulb thermometer and it is denoted by WBT. Dew point temperature. It is the temperature of air recorded by a thermometer when the moisture, or you can say water vapor, present in it begins to condense, and it is denoted by dPT. Now, this is the diagram of the dew point temperature. Condensation occurs at the dew point temperature. It is shown in the figure. Dew point depreciation. It is the difference between the dry bulb temperature and dew point temperature of air, or we can say it is the difference between dBT and dPT. Wet bulb depression. It is the difference between the dry bulb temperature and wet bulb temperature, and at any point the wet bulb depression indicate relative humidity of the air. This is the psychrometric chart. When we design the air conditioning, then the psychrometric chart is very important. Without that, we cannot design the air conditioning. Now, in psychrometric dry world temperature, then in this diagram it is shown that the vertical lines are called the dry valve lines, and in base it is mentioned then dvt from 20, 50, 105, that is called the dry valve temperature scale. Wet valve temperature, in this psychrometric chart here it is shown then the inclined line, that is called the wet valve lines, and the temperature denoted on that curve, that is called the wet valve temperature. Relative humidity, in psychrometric relative humidity is very important. Here it is shown relative humidity lines at the curve shown in the psychrometric chart, that is denoted relative humidity. 20% relative humidity, 45% relative humidity, 80% relative humidity, and 100% relative humidity. That is the saturation conditions where we can say it is the 100% relative humidity. Now humidity ratio, or we can say specific humidity or humidity, it is shown in the right hand side of the psychrometric diagram, that is humidity ratio. They mentioned here 0.01, 0.02. Dew point temperature, when the horizontal line indicated in the curve, that is called the dew point temperature. Here it is mentioned from 20, 50, 80, etc. Now specific enthalpy, inclined line is called the specific enthalpy line. It is denoted in the diagram by the curved line. Specific volume line, when we want to find the mass flow rate, then it is the very important how we find the specific volume line. This is to indicate the specific volume line. The difference between the specific volume line and the wet valve temperature is that difference between the specific volume lines are greater as compared to wet valve temperature. Sensible heating or cooling, a psychrometric process that involves the increase or decrease in the temperature of air without changing in humidity ratio, that is called the sensible heating, or we can say temperature increase or decrease without change in specific humidity, that is called the sensible heating or cooling. Example of that, passing moist air over a room space heater and or clean air over the heating coils. This diagram shows the sensible heating, point 1 to 2. Then what happens here? Here temperature is increased. So we can say it is the sensible heating. Here specific humidity is constant. Heating and humidification, a psychrometric process that involves the simultaneous increase in both dry valve temperature, humidity ratio. It is called the heating and humidification. This diagram shows, when we see in the diagram, then 1 to 0, that is called the heating process, and 0 to 2, that is called the humidification. So resultant 1 to 2, that is called the humidification plus heating. Cooling and humidification, a psychrometric process that involves the water from the air at the air temperature falls below the dew point temperature. In this diagram, we show that 1 to 2, that is the resultant of 1 to 0 and 0 to 2. 1 to 0, that is cooling process, 0 to 2, that is called the dehumidification process. So resultant 1 to 2, in this process cooling and dehumidification, it means temperature decrease and specific humidity also decrease. Then sensible heat factor. When we talk about the sensible heat factor, then sensible heat factor is the ratio of the sensible heat upon latent heat. Now what is sensible heat? It's sensible heat temperature increase and decrease without changing phase, that is called the sensible heat. When we talk about the latent heat, then phase